Today we're going to talk about volume of revolution. These are a few things that we're going to discuss. Find the volume of revolution about x-axis, y-axis with a hollow, and finally some miscellaneous examples. Let's jump straight into it. What we are interested in is, for example, if we have something like that, you have a straight curve, bounded, and we have, for example, this area that we are talking about. And if you rotate this area about the x-axis, how do we find this volume that you just saw? That's that we want to discuss today. Alright, let's jump straight into this. There are two kinds. One is rotate about the x-axis, and one is a rotation about the y-axis. Alright. Okay. In order to determine the volume of the solids of revolution, we will slice the solid up into thin discs. Now the approach is similar to the approach that we used in finding area. Recall, we just have to recall, area is integrate y dx. How did we get there? We actually used thin slices, and we say, oh, okay, 1 is actually the summation of all these little slices of rectangles. Recall? So actually, to find volume, it's the same approach. Now let's take a look now. Let's take a look very closely at this particular function, and if we were to rotate it about the x-axis, actually it's the sum of tiny little strips. Let me just go back to this file again, and you should be able to see that. Stop this. Alright, and you can see that if I limit it to a very small width, actually the volume of this tiny little figure is the volume of a cylinder or a disc. Now, stop this. If you sum them up and you look very closely, they are actually red lines there. The entire volume of this figure is made up of the volume of the individual discs. You follow what I'm saying? So, let's consider a single disc here. Do we all agree that the volume of a single disc, which is like that, this volume of a single disc, this width is delta x, that is delta x, the radius now is actually y. So using recall, volume of cylinder is equals to pi r squared h. Yeah? So the volume of one entire single disc is pi y squared dx. Now, the volume of this volume of revolution is actually the sum of the volume of n discs. I'm not going to repeat this idea again because we have done this in area. We are actually dividing this interval into n equal parts. Yes, and eventually we are going to let n tend to infinity. Yes, so is a summation now. As n tends to infinity, dx tends to 0. So similarly, the idea is that the volume, it can be proven that volume is just integrate from a to b pi y square dx, because you're actually summing the individual strips up like that. Okay? Can? Alright.